Today's video, I'll be talking about countermeasures against top attack anti-tank missiles like the Javelin, FGM-148, ATGM or anti-tank missile, and there are countermeasures against infrared guided missiles. For on combat aircraft. For infrared missiles like the Sidewinder or other equivalents of that, like the AIM-9 Sidewinder, would be something like flares, right? Flares could fool a Sidewinder missile, which uses an infrared sensor, right? So the way a Sidewinder missile works is that it's attracted by the heat of target, right? The heat from the exhaust of an aircraft engine or a jet engine um, is emits a lot of IR radiation or infrared radiation because it's very hot. So the way a Sidewinder missile works is that it locks onto that heat source, right, using its sensors, and then the missile is guided to the target by the heat, right? But the way something like a Javelin anti-tank missile works is that it doesn't just it's not just attracted by the heat, right? What it does is it's attracted by the image, the thermal image of the target, right? So what the computer in the Javelin missile does is it gets that image and puts it into the computer, and that's what it locks onto, not just the heat signature. So definitely it cannot be fooled by something like a flare. It simply won't work because the flare does not look like a tank, right? Or the image that the thermal optical sight captured into the Javelin's computer, it doesn't look like that. So obviously flares won't work. So if you put something like a hot pot in the back of and towed it from the back of a tank, that also will not work because the tank, the thermal signature doesn't look like that. It just looks like a pot with something hot in it. So that wouldn't work. So the way to break this type of lock would be by using smoke. An IR or infrared smoke grenade would be able to do the trick. Something like a Russian 3D-17 IR smoke grenade. So what this does is it uses phosphorus and heats up the air and turns it into smoke, right? Makes it combust. So the temperature is hotter than that of the tank when the smoke is goes into the air, and that could obscure the view of a Javelin anti-tank missile, the imager that is. So if it can't see the target, then it can't hit the target. So that could break the lock. And a Javelin anti-tank missile has a range of about 2.5 kilometers or 2,500 meters or 8,250 feet or 1.56 miles. And the velocity of a Javelin anti-tank missile is about 300 meters per second or 990 feet per second. That's about 675 miles per hour or 1,080 kilometers per hour. So that's pretty fast. And the impact time is about 9 to 14 seconds for the missile to impact the tank. And these are various graphs of how this type of missile works. There's two types of attacks. One type is called a top attack, where the missile goes up 150 meters into the air and takes this parabolic trajectory, and basically if the target is there, it just goes down like this at a very steep angle. And as you can see, the current active protection system for Russian tanks, like the Arena system, has a maximum angle of maybe 65 degrees. This is the radar, that's the Doppler radar that is used to intercept missiles and rockets. So as you can see, the angle for a top attack, it wouldn't be able to detect it, because obviously it'd be way over the elevation angle. It'd be greater than 65 degrees, right? This is more like maybe 85 degrees or something. So if the engineers for these APS systems could maybe get a wider coverage for the missile, maybe up to 88 degrees or something like this, then maybe they could use it to deploy a smoke screen to block the thermal imager, so it could break the lock, so basically. And there's also the direct attack mode, and this functions like a conventional laser guided missile, like a tow missile or a AT-3 Sagger missile or something of that sort. Something equivalent, Russian equivalent to a tow or whatever, laser guided missile. And direct attack would be less effective because modern battle tanks, especially Russian model battle tanks, have explosive reactive armor modules on them, and those are used to defeat heat warheads. And the Javelin anti-tank missile also uses a heat warhead. It uses a tandem heat warhead. So this is a little bit this is a little bit more, because what it does is it fools the ERA block to explode before the main charge can hit the tank, right? So there's, I think it has two charges. So one to detonate the ER block, and the other one to penetrate the armor. So it's effective in both ways. And I think the best defense against a infrared guidance system is by obscuring the view of the missile, or by shooting it down, by having a Doppler radar mounted on all the tanks and having them like network to each other. So if there's any kind of warning in the sky, maybe they could put a machine gun array on the top of the tank, maybe like 3 machine guns firing rifle caliber ammunition, like maybe a 7.62 by 51 NATO, or for Russian machine guns, I guess it'd be a 7.62 by, I'm not sure what kind of machine guns they got, or any type of rifle caliber machine gun. They'd all be shooting at the target as it's being tracked in the air, and that would be probably enough to knock out anti-tank missiles, or in this case just using smoke grenades, IR smoke grenades. And IR smoke grenades are made out of different types of materials. This Soviet or Russian IR smoke grenade, the 3D6 and the 3D6M, uses different type of chemicals like hexachlorobenzene, zinc oxide, and aluminum magnesium alloys. And this is another type of ammunition called a 3D17IR smoke grenade. Red phosphorus, like I said, that heats up the surrounding air with the smoke, and that could obscure the view of a thermal optical sight. And this type of protection is called visual and infrared screening smoke. It's not the same as a smoke screen, because tanks had smoke screens on them for quite a while. I guess since World War II, I guess they had smoke screens, but that kind of smoke cannot block infrared. You will be able to see that on a thermal imager. So you would have ample time to react to a missile attack. So basically on combat aircraft, you have sensors on combat aircraft. So if you're being tracked by radar by another aircraft and they want to use a lock on you, a radar lock, to lock on a maybe some kind of missile like a AIM-120 missile, radar guided missile, or Russian or Chinese equivalent of that, or whatever. You would get your sensors on your aircraft would pick that up, and then this will give you time to employ countermeasures against it. Basically, you could use chaffs, which is kind of like aluminum foil stuff, strips into the air, which could fool a radar guided missile. Or you could use if it's a infrared guided missile, then you could use flares to fool it. Or the pilot could could do some maneuvers to dodge the missile. If it gets close enough, they would just use maneuvers to evade the missile, or they could use countermeasures, or they could do both, or whatever, to prevent their aircraft from getting shot down, basically. But for this type of technology, like for the Javelin, it can't be fooled so easily, because it locks onto the image of the target and also the infrared signature. That kind of lock is harder to break, and it doesn't have to use a laser to track the target, like traditional laser guided missiles. And a lot of countries have been coming out with countermeasures for that, like the Chinese Type 99 battle tank has sensors which can detect lasers that are focused on it. So when that happens, it could deploy countermeasures like IR smoke grenades or something, so it could avoid from getting hit, right? Or something like that. So basically, yeah. Or Russian tanks have such sensors as well, I guess. But so when people say that the tank or main battle tank is obsolete, I really don't think main battle tanks are going to be obsolete, because somebody came out with a special type of missile. So back in the Yom Kippur War, back in 1973, the Egyptian army was using, I think, Sagar anti-tank missiles. These were remote-controlled missiles. They're called AT-3 Sagars. They were using these portable missiles to knock out Israeli tanks, and they were very successful at it. But then the Israelis found out that if a missile is being used against them, what they can do is they could just start firing everything at the direction of where the missile's coming at, right? They could fire machine guns, rifles, and whatever. because you could see the missile coming at you, right? Because the missile, anti-tank missile, isn't that fast. So then, if you can shoot at the operator, because you have to keep the missile locked onto the target. You have to guide the missile to the target, so which makes you kind of exposed, right? But with this type of missile like the FGM-148 Javelin, you're not exposed to the target, right? You could shoot, and then the missile does the tracking. After you lock onto the target, the missile does the tracking automatically. So that's pretty revolutionary, because it doesn't expose the gunner to the tank or counterfire, basically. So this is a glass panel that this person has in front of them, and infrared camera is being used to look at this person. And as you can see, his arms aren't behind the glass, right? Glass panel. So you could see his arms, right? The thermal signature. But when you have this glass panel, this the infrared imager or the thermal optic imager cannot see through it, as you can see. So with IR smoke, you could do the same thing. You could obscure the view of the site, basically, thermal site. An infrared wavelength range from 700 nanometers to 1 millimeter. So that would be the wavelength of the wavelength of the infrared wave, right? So as it gets to higher frequency, the energy is increasing. So infrared ranges around 1 millimeter to 700 nanometers. So I guess if you have better infrared equipment, it would give you an advantage in seeing through even IR smoke, But there's certain materials that thermal optics can't see through, like glass panels. It's not going to be able to see through that. Or if there's like a fire or something in front of the tank or something, then it's not going to be able to see through that either, right? Or if there's like a smoke grenade that uses something like phosphorus that heats up the air around it, creating the smoke, it's not going to be able to see through that either. So thermal optics isn't the end to be all. It can't do everything. There are limits to the technology as well. And scientists and engineers developed different ways to counter it, like always, Just like when they first came out with the first anti-aircraft missiles, scientists and engineers had to solve the problem of maybe how can we counter this, right? Whenever you come out with something new, they have to find a way to counter it. So when the first people came out with bows and arrows, I guess people had to find out, how could I protect myself against this bow and arrow, right? Or this projectile weapon. So they came out with stuff like shields, different types of armor, like plate armor, leather armor, and whatever, So it's a cat and mouse game. It's not like a permanent thing. I mean, people are smart. They're gonna figure it out. Like, can't say that this is the most advanced thing and you can't figure it out. Well, you'll figure it out, because people aren't stupid. And there are smart people out there who get paid to do this type of work, right? To be as engineers and stuff like that. So anyways, that's all I wanted to share with you. And if you have any thoughts of your own, you can leave them in the comment section below. And thanks for watching.